We now need to address this general idea of changes in matter as part of our definition of chemistry. Study of the properties of matter, which we handled properties in a previous video, and now the changes it undergoes. And the good news is we can do this pretty quickly by looking at our properties, our chemical properties and our physical properties. And these characteristics are nouns, and if we take these nouns and turn them into verbs, we've got the changes, right? So if we have a property that is color, then the verb of that would be coloring. That would be the change we're looking at. If we have something that is flammability, right, the ability to burn, then we could say burning or combusting, right? So that's how we're going to handle this. We'll just take our physical properties, may be observed without changing the identity of a sample, and a physical change then is a change without a change in identity. And so let's grab our markers and take care of that. We've got physical changes, and we have chemical changes. So we had said physical properties may be observed without changing the identity of a sample. So physical changes are changes that occur without a change in identity. All right. So these occur without, an abbreviation there, a change in the identity. And we'll describe that term a little clearer as we look at chemical changes. We have these changes with a change in identity. All right? And how do we have a change in identity? Well, this is a rather important idea in the big picture. A change in identity would be some chemical reaction. And the way you can have a chemical reaction is to gain, lose, or share electrons, or breaking or forming chemical bonds. So we can gain, lose, or share electrons. And what's really happening there, in many cases, is that we are breaking or forming chemical bonds. All right, so I put this in red. It's a pretty important idea in terms of what are we talking about with a change in identity, and that is some type of chemical reaction where you're gaining, losing, or sharing electrons, and you're really breaking or forming chemical bonds. So if these things are not happening, then you have a physical change. There's no change in identity. So what would be an example of something where we do have a change in identity? Well, if a chemical property was flammability, I said moments ago that the verb form of that might be burning. Or in general, you could say oxidizing. Right? You could have something like, if you have oxidizing, you also have reducing. Oops. And in general, we had things like reactivity with something. So you could say reacting with something else. All right? So those would be examples of chemical changes. Now, in terms of physical changes, there's a trap that I'll mention in a second here. But we had said, like, color was an example. So what's a physical change? If I color in this piece of paper, it's still a piece of paper. That's a physical change. So coloring. Right? Cutting. Now, that's not breaking or forming chemical bonds. It's actually overcoming intermolecular forces. But if you cut a piece of paper, you still have paper, right? Or bending. Or anything of the genre shaping. And now the trap that we need to watch out for, phase changes. Right? And in terms of phase changes, we might talk about melting or freezing. And it's not obvious that you have a physical change taking place because it seems like things are changing rather dramatically. But with a closer look, if we take the example of water, we have water as ice, That's a solid, so that'll be solid. We have water as a liquid, and I'll put L for liquid. And we have steam, which is a gas. I'll put G for gas. And so all of these things are water. In going from ice to liquid water, it stays water. It's still water. Solid water, liquid water, gaseous water. And so we're not actually breaking or forming explicit chemical bonds. We're overcoming intermolecular forces. That's what determines those phases. So watch out, a phase change is an example of a physical change because there's not a change in identity, right? It's really a change in the distance between the particles. And that's a classic example.